Hey everyone, good morning, good afternoon, good evening. My name is Paul Menard. I am the marketing consultant at Atombeam and the host for the webinar. This is our first webinar of the customer series. We have a great group of speakers today from Ericsson, Cirrus, Inductive Automation, and Atombeam. Gentlemen, if you wouldn't mind introducing yourselves, starting with Michael, get started.
Yeah, great. Yeah, good morning, everyone. Michael Dickens. I'm a solution engineer here at Point. I lead our OEM and technology alliances business. I've been working at Ericsson about 15 years now. And our biggest focus, over here is networking engineering, right? We talk about applications and running those, but we always need the network to be able to communicate those. So my background has been building those networks from the data center to edge, and that's why I'm happy here to talk with you all.
Thank you.
Hello, everybody. Arlen Nipper. I am the CTO for Cirrus Solutions and been doing industrial automation for 46 years. So a lot of experience, and about halfway through that journey, I had the great opportunity to work with Dr. Andy Stanford Clark and was one of the co-inventors of MQTT.
Hello, everybody. I'm Travis Cox. I'm the Chief Technology Evangelist for Inductive Automation. We are a software company and providing Ignition, the industrial application platform. I've been with the company for 20 years, and over my career, it's really been to work with our customers and partners to help put best architectures together, best practices, and help get these solutions integrated. So I'm happy to be here today.
Good morning, I'm Jesse. I'm the VP of Sales Engineering with Atombeam. I've been through quite a lot of different industries and the variety of the work. Start with the oil and gas focusing on the signal processing and oil explorations. I also spent quite a lot of times in the telecoms and eventually to IP and software-defined network, big data, and machine learning.
Thank you all so much. So in today's session, we're going to be talking about the drivers to a modern architecture. Each presenter is going to highlight how their solution contributes to the modern architecture from the edge to the cloud. We'll then show a demo on how the overlay of the Atombeam ecosystem can reduce bandwidth. We'll demonstrate the before and after there. Afterwards, we'll follow up with a Q&A, summarize anything that we may have covered. You'll be able to request the white paper that we just created specifically for the webinar. So talking about the trends, if we look at edge to cloud drivers for the IoT and SCADA architectures, the expansion of the Internet of Things in the digital age is enabling enterprises to create innovative digital experiences, develop new service offerings powered by smart IoT applications, which enhances productivity. Across diverse industries, IoT-based applications are driving exponential growth, which emphasizes the role of edge computing in managing such large-scale data flows. But this expansion is creating challenges on how to manage the increased bandwidth demands effectively. These transit networks often become congested and chatty, which limits the ability to utilize all available sensor data. Ericsson, Cirrus, and Inductive recognize these challenges, and as the front runner of edge-to-cloud solutions, have joined to provide a modern architecture. Let's turn it over to them.
All right, real quick, I'm going to tell everybody a story. So in 1999, Phillips 66 just got a new TCP/IP-based VSAT network. Now, they had a poll over that network, and any poll response protocol really consumes 100% of the available bandwidth. So we were working with Phillips 66 on this project, and they had seen a publish and subscribe infrastructure from IBM. And what they said, the challenge is that can we decrease the latency of getting all of our field data? Using conventional round robin polling, it was taking them up to 15 minutes to get their alarm and all of their actual field data. It needs to be bidirectional because it is command and control. And they would like a one-to-many architecture where they could have multiple field devices in the field feeding different applications. So really, Philips needed a better way to utilize their TCP/IP-based VSAS system. Next slide. So the design goals of MQTT when Andy and I started was, first of all, it had to be simple. We were relegated to 8-bit processors in the field. It had to be efficient. Every byte of overhead of our transport was going to add $5,000 a month to Philips 66 communications cost. Had to be bidirectional, had to be stateful. And by that, you could only do report by exception if your publish and subscribe system has state. And I put in there open. We left it open or we wouldn't be having this conversation. And in 1999, there was no cloud and nobody was talking about security. So really at the end of the project, what we were able to do was meet all of Philips 66's requirements. Our data latency went from 15 minutes to 12 seconds. Alarm latency was reduced to 5 seconds, order of magnitude. Command verifications for the human operators was less than 5 seconds. With the MQTT brokers, they now had a one-to-many architecture to access multiple field devices, and they were able to reduce their data communications costs by 85%. So in 2020 hindsight, now that we look at it, MQTT has been out there for 25 years now. If you look out in the world today, there are over 10 billion MQTT clients doing stuff all over the world. We let TCP/IP do the heavy lifting, but what does that mean? That means today we get to stay up with the latest security technology. So if a new security technology comes out tomorrow, we get to take advantage of it. The security standpoint is there are no ports open in the field, and it was designed for real-time mission critical. But ironically, over the last 25 years, it's also been adopted by IT. So it's interesting. For the last 25 years, MQTT was the only way customers could effectively reduce their overall network bandwidth usage until now.
That's right. So I'm going to show you an architecture here of what we've been doing in the SCADA IoT realm for quite some time now. And this is leveraging the protocol that, leveraging MQTT, and in particular with IoT data, a payload specification called Sparkplug. And we'll talk more about that here today. But what we are doing is we have to have on-premise solutions. So we've been deploying, for example, Ignition Edge on-prem to have local HMIs, SCADA systems. But all that data that's there can easily be published up to the cloud through MQTT to be available for all cloud services and to be available to create dashboards, provide to more people. And so we're leveraging the incredible efficiency of MQTT to publish tons of data out there by exception to a cloud MQTT broker. And most providers, AWS, Azure, Google, GCP, they all provide brokers up there. There's lots of different options out there. As it being a standard, there's lots of products you can work with. But by getting into that broker, you then make it accessible to many applications up there, including going into Ignition from a SCADA standpoint or a dashboard standpoint, going into AI and ML tools, digital twin services, all these things where you can make full advantage of that. So these architectures have enabled companies to really get operational data into the cloud and to make data more accessible to a broader people because of the efficiency we've got out of MQTT. So today we're going to take this and show this architecture going one step further. We can get even more efficiency. Before we do that, I want to send it over to Michael to talk about how we've deployed Ignition at the edge in a more modern way.
Thank you, Travis. I want to talk to you a little bit about, Ericsson Enterprise Wireless a little bit. If you want to go next slide, we're really focused on, we started with 3G, went to 4G, now we're at 5G. I do believe that anything that can go wireless will, and that's been our focus here. Wires will always be there, but if you can make these communications and these tough environments communicate in a better way, that's our focus here at Ericsson Enterprise. We're taking the technologies of 5G and be able to use them in multiple applications, from the edge to the core to the cloud, and how those applications go across all those. Makes it a lot easier to be able to grow your enterprise or your OT technologies when you can make them wireless and not have to put those there. Next slide, please. So at Ericsson Enterprise, if you look from the left-hand side to the right-hand side, right, we kind of want to line up in the networking world how we do these connectivity pieces. We do a lot of our portfolio do use common classic technologies like Wi-Fi and Ethernet, but we like to put the focus of 5G with connectivity in those applications, because not everything is 5G enabled. We build these applications from our devices, from the very far edge, what we're kind of talking about today, but we also build what we like to call private 5G. And then we also look with public 5G with the public carriers as well. So you'll see Ericsson across those different things. Now, on top of that, we want to make an optimized solution for 5G. Everyone hears about SD-WAN or SASE and these technologies, but Ericsson Enterprise focuses on being able to deliver those technologies that are 5G focused and optimized across those. So having multiple links and being able to do performance testing across those and be able to do application delivery, as we're going to talk about today, to get more efficient, we bring all those together and make sure we are actually making a secure solution from end to end. We have a lot of different items in our portfolio that come across that, but I just want to give you guys a little glance here. So let's go ahead and go to the next slide, and we'll talk about some of those edge devices that we're talking about today. We do build a lot of purpose-built hardware for these type of applications. A lot of what we're talking about today is OT, so you'll see our ruggedized devices and in-vehicle devices on the right-hand side. But we do find that, in a branch or a small office or, in a school bus or, wherever we may be having these devices deployed, 5G is a great connectivity solution, and we have hardware that can go across all these. Some of them do support edge compute, some of them do not. So there could be a mix of, compute boxes for running Atombeam and inductive automation, or you could be running it on these devices, as we're going to show in a demo here in a little bit. Next slide, please. This is just kind of showing an example of how we deliver these applications that we're talking about with a Docker container. We do a lot of orchestration of those applications from what we call our NetCloud Manager. We're able to deploy those to the edge, which again, we're going to show you in a demo a little bit, but here's kind of a nice little way of how we make that happen. The nice thing is that once that's running at the edge, we have a lot of interfaces that we communicate with your application or devices, whether that's wired or Ethernet, Wi-Fi, Bluetooth. There's a lot of communication that we have here, but this just shows you how we orchestrate that. Next slide, please. This is what we're talking about specifically today, just deploying the Atombeam to reduce that congestion. We're going to show you that demo here in a second, but this is a nice little flow. Travis will talk to this a little bit more about how we're doing in this and how it flows for the pieces. But you can take a look here is how we can have devices already in the field. For example, a Cradlepoint router could be out there. We can deploy that today without having any issues of having to go out and rip and replace and put new hardware out there. So this is kind of showing you that we really can start, you can take advantage of this today if you're already running Ericsson's Cradlepoint routers. Next, I believe I'm going to pass it off. Let's skip this slide. I'm going to jump it right to Travis and have him pick it up from here.
Perfect. Thank you, Michael. Go to the next slide here. So what I want to show you is what what that architecture looks like with MQTT and Ignition. So before I do that, though, just for those of you who might be new to Ignition, our software products, it is a universal application platform for SCADA, MES, IIoT, and a lot more. It has an unlimited licensing model, so you can connect as many devices, bring as many tags as you want or data points in, have as many visualization clients as you want, and you can get that data wherever you want it to go. It's based on a server license that's fully unlimited, fully cross-platform to run any operating system, can be containerized, and that's what's really important to be able to run on Cradlepoint. And it's based on IT standard technologies. We don't do anything proprietary. It's all about using open standards, MQTT being a big one. And there are many others like OPC UA, and we leverage SQL databases and REST APIs and all sorts of things you can connect with. It provides industrial strength security and stability server client architecture, and allows you to create any kind of application that is fully web managed and web launched, meaning that it's native HTML5, you can get it anywhere, including your phones and tablets, especially the native app for those devices allows you to use the device as an extension. You can use the GPS, the accelerometer, the Bluetooth low energy. You can use all these amazing sensors that are on these devices and extend your applications. So Ignition's really providing these SCADA, full SCADA solutions on premise, along with being able to get that data to cloud infrastructures and even provide cloud applications that people can work with, completely modular platform that you can scale with. All right, next slide. So there are 3 different products for Ignition. We have Ignition Edge, and that is typically what we deploy near assets in the field. So it could be on a local critical asset in a plant, it could be remote field, is where we can connect to that data locally, get that data in, and be able to get that to a centralized system, along with being able to provide a local visualization or local HMI on that critical asset. The central one is Ignition Standard, where it's typically a plant-wide operations management tool, where you can get a complete SCADA system, bring all these disparate systems and data together into one unified view, and provide that information to anybody within that plant. And further, of course, we can then take that data to the cloud. We have Ignition Cloud Edition that we're going to show here today that allows you to kind of build enterprise dashboards and aggregate all that data from all your sites into one view. And that's where, if we're leveraging MQTT, we can get into other applications like machine learning analytics and business intelligence. So this is our kind of full suite, and we're going to show an edge to cloud journey today with Ignition Edge running on Cradlepoint, going up to the cloud. We're using Ignition Cloud Edition to create a dashboard. So we'll see that here pretty soon. All right, next slide. So before we did MQTT, I want to kind of point out the legacy SCADA architectures in that a SCADA system would connect directly to the PLCs or RTUs or devices on the plant. And with that, we would bring that data in, we'd pull those PLCs, that pull responses, as Arlen was saying earlier, and we'd bring that data into a system that we isolate that data to each of these different systems. So SCADA got its data, MES got its data, and if they needed overlaps, they would connect to those devices, and it created this very coupled architecture. And this is not really good for scaling. It's not really good for democratizing data. So a new architecture, if you go to the next slide, is about leveraging MQTT. And this is where we can actually have edge devices right in front of these PLCs and RTUs that can pull data locally, but then publish when it changes by exception to MQTT, through MQTT to a broker. So it's very much pub-sub architecture. These devices publish data in, and we have applications that are consuming that data. And it's a very much a decoupled architecture. The devices don't have to know anything about where the data is going, and the applications don't know who the end device is. They just can get that data, all that information from that broker. And now this is really not only is this great in terms of getting data to the cloud, but a lot of companies are leveraging this kind of architecture just on premise to be able to get all of their asset data, all of their operations data into an infrastructure they can take advantage of through different applications. But of course, nowadays, leveraging cloud computing and cloud services, there's a lot of availability there. This is a really great way, modern architecture to move operational data around. All right, next slide. So that's what we bring back to this diagram here. I wanted to kind of bring us back to our architecture that's kind of the before architecture standard we've been doing for a while. And we have Ignition at the edge, publishing data to the cloud. So what I want to do is actually show you this working. And then when we get to how this can get better with leveraging Atombeam and Neurpac, how we can make this picture even more efficient. So I'm going to share my screen here, and we're going to show the first part of this. So what I have up right now is actually the NetCloud from Ericsson and Cradlepoint. And so this is a device, a Cradlepoint device that we have. And what we can do is easily deploy Ignition or various containers to that device. And now this device happens to be in Michael's office, and I'm connected to the NetCloud from my computer. And what I'm going to be able to do is go down to our containers, and I can actually see Ignition's already deployed, but we can easily add new projects, which are just basically containers that we can deploy. And you can see this is using Docker Compose, using Ignition's image that we have through Docker, easily deploying Ignition Edge on this device. So now that we have Ignition deployed on the device, we can go over here and you can see this is the Ignition server. I'm going to go ahead and log in to the server. And what we've got going on in this is we've got this ignition server connected to operational data. So it's connected to a bunch of devices. So here we've got a bunch of simulators that are just programmable simulators. I don't have real PLCs here that I'm connecting to, but I've got a bunch of simulators that we can work with. And that provides a lot of data points, what we call tags. And so you can see here, I've got the smart factory with different lines. Each line, I've got different kind of assets. There's a conveyor, a haul off, and there's various data inside of that. Go line 2, got a CNC machine. I got a conveyor in there, a lathe machine, all this information along with energy usage. So I get like KYZ, energy usage, all this data that we have in Ignition from connecting to the assets on the plant floor that we want to get up to the cloud. And so very, very easily with leveraging Ignition on that cradle point, I can use MQTT. And you can see here, I got MQTT transmission. And this is actually what's responsible for publishing that data. So we're connected right now to a cloud broker. And this cloud broker is one that we can publish all this information into. And this is going directly into an AWS infrastructure right now and leveraging just straight MQTT and Spark plug to get the data up there. And then what we do have is a dashboard. So I've got a dashboard in the cloud that is all that data is coming into. I'm displaying that information, both real-time and historical data. There's alarms that are coming in here. And in fact, I can actually see if I go in this dashboard, if I look at the actual tags, you can see there's my IA Edge device, there's my smart factory, all the actual data. Here's that conveyor, it's coming up here. I can go into the factor energy, I can look at the energy usage, and now we're trending that information in the cloud. So we're taking full advantage of that data. So this is, again, leveraging MQTT, getting that data up there. All we did is connect our central system. Let me go into this real quick. And I'm connected to the central system to that same MQTT server. So that's how this infrastructure is working here. So with that, what I want to do, let me go stop sharing my screen. Hopefully this, has the screen been, did it go away or is it still there?
We have the slide now.
All right, perfect. I can't see that part of it. Let me get it back. All right. So with that, we're going to change it over to JC. Let's talk about how can this get better, JC? How can we leverage your technology to make that infrastructure even better?
Thank you, Travis. How can we get it better? This is a very good question. We have seen the IoT technology evolve quickly in the last few decades. However, the traffic and the demand has increased in the even faster pace. So IoT traffic overload is a constant problem for today and also for the future. And this is what the Atombeam Neurpac is designed to resolve. So Neurpac, what's a Neurpac? Neurpac is a machine learning-based real-time lossless data compactions. So how does it work? It's just like any machine learning to create a model. Neurpac will go through the training phase to create the codebook. During the training phase, Neurpac will analyze the frequency of data patterns in the historic data. Based on the frequency of the data patterns, the trainer will then generate the codebooks, which optimize the pattern to the code word mappings. The higher probability patterns will then be assigned to a shorter code words. So let's just use the 120-bit pattern as examples. The highest frequency patterns can be assigned as small as 3 bits. And the less frequent patterns were then assigned to the longer bit. So now you can see how the Neurpac can so effectively compacting the data. Of course, what I'm describing here is really the basic concept. The detail is a lot more complicated. This machine learning process is done prior to the real-time data compactions. By taking this heavy computation process of the data compactions, it greatly simplifies the compaction process. So in the compaction, it just really look up the lookup table and replace the data with a code word. And this is how the Neurpac can compact the data in a matter of microseconds. Since the Neurpac operates in the bit levels, it's really agnostic to the data type. It doesn't really matter what kind of data type. It can be ASCII, CSV, JSON, or binary data. Neurpac can compact quite well on the data. And the other interesting characteristic of the Neurpac is can deliver the similar compaction ratios regarding the packet size. So whether the packet is the 8 bytes or 8,000 bytes, Neurpac will deliver the similar compaction ratio. And this is very important in the real-time data compactions. And this is also where the regular compressions fail to deliver. We all know the compression is only effective in the large data sets. And this is the another reason why Neurpac can be effective in the real-time data compactions, and compression fail to deliver that. Atombeam has done an extensive study on the different type of data from the different vertical markets, such as IoT, telemetry data, tracking, control data. Neurpac delivered in average 75% compaction ratios. That is, for the 100 bytes data packets, it will reduce to 25 bytes. So this is the quick summary of the what the Neurpac can do. Now let's go to the next slides. In the next slides, we'll focus on the implementations. We all know the any great technologies without ease of use will probably going nowhere. This is why Atombeam pays a lot of attention on the details of the Neurpac implementations, with a focus on making Neurpac into the super simple for deployments and ease of use. And this is the our design goal. In addition to that, we also want to make sure Neurpac can be seamlessly integrated with any existing deployed service and also for the future service. So with this design goal, ease of use, and also the seamless integrations, we chose the cloud SaaS architectures for Neurpac solutions. The majority of the Neurpac functions are already implemented and running in the AWS cloud. This is including the trainer, decoders, management function, monitoring, and also user portals. And the only components that we need to deploy outside of a SaaS is the encoders. And the reason being is that encoder has to be very close to the data source, and so that it can compact the data in real time and deliver to the destinations. And Neurpac encoders is designed with the Docker containers approach. And we purposely designed the encoders to be a very lightweight footprint. It can be deployed to any edge device or routers that support the Docker containers. So to illustrate the Neurpac real-time data compactions and ease of use and seamless integration with the existing service, we have prepared a short demos. And this demo will follow what Travis has just demonstrated. And we'll take that demonstrations and migrate that into the Neurpac solutions. So in order to illustrate the idea of the ease of use and the simple for the deployments, we have created the slides, the 3 slides to illustrate the 3 simple steps to integrate the function with the Travis demos. So the step one is to create the connectors, which defines the end-to-end data compaction flow. A connector is a logical entity that links the source of the data, encoded SaaS service, and the destination for the decoded data. So together, this becomes the complete end-to-end service for the data compactions. And this is illustrated with the gray lines, with the dashed lines in between. And so right now, once we create the connectors, and the connector, the Neurpac portals will create the file called Docker Compose file. And this Docker Compose file can be used for the deployments. So in the previous demos, Travis has the ignition edge publish the data directly to an MQTT broker on the cloud. And the ingestion servers over the SCADA system subscribe to. In order to enable the Neurpac compactions, what we need to do is taking the data traffics, ingest data traffics, and put it into the local MQTT brokers in the cradle point routers. That's where the encoder will subscribe to. So you can see the encoders will subscribe to the MQTT brokers. And once the MQTT broker receives the data, it will compact the data and send to the Atombeam decoders. And where the decoded data will then be published to the cloud MQTT brokers. And that way it completes the loop of the traffics. And with that, this simplifies the whole connection replacements, and there's no impact on the existing service. So once the connector is created, Neurpac will create the Docker Compose files for the encoder containers deployments. So this is a completion of the first step. Then the second step is physically deploying the encoders in the edge device. And the edge device can be any router or system that support the Docker containers. In this case, we're using the Ericsson's cradle point routers. And this deployment process is greatly simplified by the Docker Compose. Just copy and paste the Docker Compose file generated by the portals to the cradle points routers, and then enable the containers. Once the encoded containers is enabled, it will automatically connect to the ingest MQTT brokers and also the backend SaaS service. So this is illustrated with the red lines. And so at this point, the service is ready to receive the data. Now we need to go to the third step. It's simply cut the traffic from the directly into the cloud MQTT brokers and ingest the data to the local MQTT brokers. Once we cut the traffic over, since all the service is already running, you will immediately see the traffic going through, and then you will start to do the compactions. So at this point, we are ready to run the demos. So as discussed earlier, now the first step is to create the connectors. In order to create a connector, we need to go to the Neurpac portals and log into the portals. And once we log in and go to the connectors, you will see the button of the create connectors. And you click on the create connectors, then it will pop up the dialog box. allow you to enter the informations. As I said earlier, majority of the work has been done in the SaaS. So really over here, we just need to enter the two information. Where is the data coming from? And where is the data going to? And as Travis has demonstrated, the data is really coming from the ignition edge to publish the data to the local brokers. So we'll need to use the local brokers. And this MQTT 192.168.0.1, this is the local brokers inside the Cradle Points. And the other is the topic. What topic are we subscribing to? So once we define those two, now we can go to the delivery. In the delivery, now we need to put the data into the cloud MQTT broker, which is illustrated down below here. And another important point is the topics. We want to mirror the data source topics. What this means is that every topic comes in will then be delivered to the destinations. So the destination topic will be totally identical to the ingest topics. And this is, totally avoid the any changes needed for the SCADA servers or ignition servers. So once we finish this, we can save the data, then it will create the connectors. And also along the line, it will create the Docker compose file. And this Docker compose file will then be used for the deployments, for the encoders. And we can go to the next step.
Okay, so
now in the step 2, we'll physically deploy the encoder containers in the Cradle Point routers. In this step, we need to go to Ericsson's NetCloud portals and to add the new projects. And once we click on the project, we can paste the Docker compose files to the projects. And then the Ericsson's portals will then start to create the containers. And this would take a couple minutes. Once you save and commit the changes, it will take a couple minutes to create the Docker containers. And then once the decoder container is established, it will automatically connect to the ingest MQTT brokers and also connect to the backend SaaS service. So at this point, the Neurpac is ready for the processing the data. Now we need to go to the third step. And in the third step, we just need to cut the traffic over from the ingest to the MQTT brokers on the cloud side into the local side. And I'll leave this on to Travis.
perfect. So thanks, JC. So as you can see, we have Ignition Edge deployed there. We were going directly to the cloud before, but we also have a local MQTT broker also deployed to Cradle Point. And then we have the Atombeam connector that's ready to go. So the Atombeam connector is connected to that local broker already. It's up and running. But the Ignition one right now is still going to the cloud server. So we're going to go over here to our Ignition server and to the edge side. Instead of going directly to the cloud, which are connected now, I'm going to enable the local broker. So we're going to route all that traffic now to the local broker that's on the same Cradle Point that Atombeam connector is working with. So if I edit this connection, I simply come over here, enable it, come down the bottom and save changes. Once I save that, you'll see that the cloud one will not be connected anymore. The bottom one is going to be connected. We're now connected directly to that local broker on that device. So all that data is being routed now directly to that broker there that the connector is working with. And if I go look at my applications in the cloud, there is no change. Nothing I have to do in the cloud. All the data is coming in, as you can see, the same exact way. In fact, if I go and look at the actual data points here, let's take a look at our smart factory line 1 conveyor. That data is coming in and changing, as you can see right now. If I look at my my factor energy, all that energy data is coming in. We're still historizing that data, no loss of that information. We are just routing the data now through Neurpac. And of course, that gives us something, right? We're doing that because it's giving us that compaction at 75% savings on top of what MQTT already does for us. So if I come over here to back to Atombeam and go back to that connector, how do we know what's happening? So we got to go look at, you can see the connectors running, but how do we know that we're getting that savings? So we're going to come in here and go to our statistics, and you can see that now that code book is in there. It's now delivered, and we're starting to see the data is now going through that compaction algorithm, and it's getting it to the cloud, delivering to the same broker lossless, but we're now saving 70% right now, 69.96, and we've seen it go upwards to 75% of savings on the bandwidth. So if we keep letting this run, we'll see more data points coming in here. But as JC noted earlier, right, when you very first start this whole thing, it has to build the code book. So normal data is being passed in. Once it has enough data and the code book's built, the encoder and decoder share that code book. And then now that the encoder is compacting it, getting it up there, and ultimately that's decoding that data and sending it to that same broker. So we're leveraging this service to give us that kind of savings. So if I refresh this again, you see I've got now another data point coming here. You can keep watching this. Now we're at 70.71% savings. Quite a bit of savings on top of what we already had with MQTT. And my applications remain the same. The only change I did within Ignition was simply route the data to a local broker that's on that cradle point that Atombeam connector is using. It's incredibly easy to deploy, and it gives us a tremendous amount of benefit. So for that, I'm going to send it back over to you, Paul, to talk about the benefits.
Awesome. Thank you so much. Hold this back up. You guys can see that okay?
You have it's a note slide that's up.
Yeah.
How's that?
Yeah.
Perfect.
Much better, much better. So thanks so much, JC and Travis. Awesome demo. Hope you guys got something out of that. You can really see the benefit of what you get with this deployment. Just as a reminder, what we just covered. So now access to standard sensors and data can be transmitted because the bandwidth, which will provide the ability to add more services and devices, enhances customer experience, resulting in increased sales and customer loyalty. And also, the reduction in bandwidth will reduce the cellular and satellite costs, and providers can use that saved bandwidth to add more customers, which is incredible. So some call to actions for the meeting today. We did create a white paper that kind of follows the same trajectory. If we could put that in the chat, that would be amazing, but it's also on our website, and we'll send out a notice afterwards so everyone can read it and take a look, kind of reinstate some of the things we talked about here today. If anyone wants a demo, any questions, info@Atombeam Tech, please reach out to us. We're happy to answer any and all questions that come up. If you want to meet with us, just kind of go over how it would look for you, please let us know. I think that covers the main topics of the call today. I think it would be a good time to take a couple questions and answers if we have any that came through. Let's take a look. So I'm going to throw one out, and let's see if any of our speakers would like to tackle it. Please feel free to do so. So question here. Are there limits on the effectiveness of Atombeam algorithms with increasing bandwidth, i.e., will it scale to much larger bandwidth channels? So is there a limit, or can it scale endlessly, basically, is the question.
In terms of the data processing, is that what you were asking?
Yeah, in terms of the bandwidth.
Okay, so in terms of the bandwidth wise, there's no limitation per se. We can process a lot of the data. And in the trial with the customers in oil and gas, we are able to process the 9-10 megabytes per minute data continuously 724. And we can scale to an even higher.
I'll throw out there.
Hope this answered the questions.
Yeah, and I'll throw out there that the data on premise, like with Ignition Edge, where we would have been publishing to the cloud directly, we're going to publish that to a local broker. So it's always good to have a local broker there that can handle the bandwidth there, that then the Atombeam connector will subscribe to and publish up through their code books. So you have to have the infrastructure locally as well, but the cloud infrastructure is infinitely scalable. It should handle any kind of workload.
Awesome. Thanks so much. And with that, do we see added latency?
The latency is minimal. In general, since this is a lookup table and replacing the data with the code word, this has been done in microseconds.
Yeah, and then the application side in the cloud, if they look at the Ignition, if we did control, as Arlen said, this has to be command and control. Not everybody's going to do control from the cloud, even though you can do it securely. But if you did do control, that you get that message being sent down. In milliseconds. I mean, typically it's within the latency is going to be your actual network connection, internet connection, than it will be anything else. But it's incredibly fast. Changes are instantaneous.
Awesome. Thank you. Fantastic. Let's see, take a look here for some more questions. One moment. So another question here. If we want to migrate our current cloud SCADA architecture to a system with Cradlepoint routers so we can use the Atombeam Neurpac, who is a good resource?
Michael, maybe a question for you.
If I can get off mute here. Yes, absolutely reach out to us. Even myself, I'd be happy to use that. But we have account teams that can help you and also our partners.
Fantastic. Thank you. And I'll send out a reminder after this that has the contact info for all the companies that were participating today in case you wanted to reach out to them individually. So please be on the lookout for that.
And I did also want to mention, Paul, real quick, that in terms of customers, if you don't have Ignition on premise already, you have other tools, that's fine. You can easily deploy Ignition Edge on a Cradlepoint in parallel with what you're doing already and get that data from the plant floor, bring it in, model that data, and then get that delivered up, to cloud infrastructures to leverage a lot of the great technologies there. I mean, we see customers who want to really do two main things. They want to store data in the cloud, with that context into different data lakes and databases. They want to then create enterprise visualizations, and create dashboards, read only, so they can look at that data. And then down the road, when they have enough of it, they're going to start looking into AI and ML and those kind of services there. So it's a really great way to start your kind of digital transformation journey and do it in a way that is very cost effective and efficient.
And with that, does the data reduction impact the energy consumption?
From the high level standpoint, that yes, it will. Since you reduce the data, minimize the much of the bandwidth on top, with the TCP, you are able to squeeze more data packets in one TCP transfers. So take the example of the 1,000 bytes over 1,200 bytes data packets. Now reduce by 75%, it becomes 300 bytes. And you can have 4 or 5 data packets that transfer in one TCP. And without the compaction, it would take 4 or 5 TCP transfers. So that can save the energies.
And what's the topic on that, JC?
Sorry, what's the topic?
Like the sensor metric?
I'm sorry, I didn't catch your question. Can you say one more time?
Well, the question is just what is the topic, but I'm assuming that's what they're referring to.
Oh, what's the topic? Okay, the topic is the MQTT topics. And MQTT can create a hierarchy topics that can help you to organize your data.
Yeah, to add a little more to that, and with MQTT, you can publish any kind of data you want on any topic. So I can publish a JSON structure, I can publish a string, I could publish a binary format, anything I want on any kind of topic. Within Ignition, in the industrial world, there's a standard out there called Sparkplug, and Sparkplug is a payload specification for MQTT that is specifically for industrial data that provides data, data integrity, making sure that we know the connection, the state, and all that, along with data context, contextualization, and a lot of efficiencies that are gained with that. And it's so that you can have the system that is completely auto discovery. Connect, you can see all the data that's coming into it. So, but you could use any kind of data you want. This would work with any kind of MQTT data that you have.
Beautiful. Well said. Thank you. I think this is going to be our final question for the day for Michael, if you don't mind, but it's are Ericsson routers advantaged over other routers or networks for using Atombeam?
Fun question. I would say, Atombeam is built on you can run in Docker. And so any type of application or router or device, you can run this application there. Our unique piece here is that we're bringing the security and the 4G, 5G networking with our routers, which is usually a unique piece for us. But if you have other devices or even Raspberry Pis, things like that, where you want to run this software, you absolutely can.
Perfect. Thank you. Well, I think that concludes the Q&A portion. If we didn't get to you or if you have anything, please reach out to us. We'll be happy to answer anything. Thanks for attending. Appreciate it. We got a lot of people on, which is awesome to see. Like I was saying earlier, this is just the first webinar we're doing as part of our partner series, working with people that use our stuff on a regular basis. So our next webinar is going to be coming up on February 4th with Viasat. Please look out for details with that, and have a great day. Take care, everyone. Thank you.